This video focuses on charging by conduction and charging by induction. If you recall, there are three ways to create a static charge: charging by friction, charging by conduction, and charging by induction. Charging by friction is when you charge two neutral objects made of different materials and you rub them together. Here we have human hair and a comb. When the hair is being combed, the electrons will transfer from the hair to the comb, making the comb negatively charged and the hair positively charged. We know this because we can refer to the electrostatic series or the triboelectric series chart, and we'll be able to tell which of the two objects will have the stronger tendency to gain electrons, and thus that's the object that will become negatively charged. With charging by conduction, there are two types. The first is between a charged object and a neutral object. In this case, the neutral object will become charged with the same type of charge as the object that touched it. Here we have examples using electroscopes. The first image is of a neutral electroscope. There you'll see that there's an equal number of protons and electrons, and that's why it's neutral. This all changes when a charged object touches it. In the first figure, for figure A, when a negatively charged ebonite rod touches the neutral electroscope, the electrons will move to the neutral object, then making it negative. You'll notice that the leaves are now spread apart because like charges repel. In the second figure there, we have a positively charged glass rod. When it touches the neutral electroscope, the electrons will move from the neutral object to the positive object, then making the neutral object positive because then the electrons will have transferred. Similarly, the leaves are spread apart because like charges repel. The second type of charging by conduction is between two charged objects. In this case here, we have two objects. The first one there is negatively charged, and so is the other, but one has a greater negative charge than the other. The contact between the two causes the electrons to be transferred between the objects until the charge is balanced. Last but not least, we have charging by induction. That is when a neutral object is charged by bringing another charged object close to but not touching the neutral object. Here we have a negatively charged balloon and a neutral wall. When the negatively charged balloon is brought close to the neutral wall, then the electrons in the wall move back, so move away from the balloon. You'll notice that the protons don't move, it's just the electrons that can shift. So then that makes one side of the wall positively charged and the other side negatively charged. That is called induced charge separation, when there's a shift in the position of electrons in a neutral object, and this occurs when a charged object is brought near it. Grounding is a process of connecting a charged object to the Earth's surface, and that provides a path for the electrons. This allows an object charged by induction to retain or to keep a charge. In the previous example with the balloon and the wall, once that negatively charged balloon moves away, the wall returns to normal. And so grounding is a way that an object can keep a charge. In order to retain a positive charge by induction, we need to have a negatively charged object. In this case here, we have a negatively charged ebonite rod. When it comes near the neutral electroscope, it repels the electrons in the neutral electroscope, and that's why you notice that the foil leaves are apart, because that negative ebonite rod, that force, is pushing all the electrons down to where the foil leaves are, and like charges repel. That's why the leaves are apart. If you were to move the ebonite rod away, then the electroscope would go back to being neutral. However, if we want it to keep a charge, in this case a positive charge, we need to make sure that the ebonite rod, the negative ebonite rod, is still close to the electroscope. Then we put our finger, we touch the electroscope, and that provides a pathway for the electrons. Because like charges repel, that negative ebonite rod will want to repel the electrons within the electroscope, and so then the electrons will move from the electroscope into your finger. Then once you move your finger and the ebonite rod away, then the electroscope will be left with a positive charge because it has lost some of the electrons. In this last scenario, if we want to charge by induction and retain a negative charge, we need to use a positively charged object. You know that opposite charges attract, and so the electrons from the neutral electroscope will move up the electroscope because it's attracted to the positive charge. When you ground the neutral electroscope, you're providing a path for the electrons to go towards the positive influence. Opposite charges attract, and so electrons will travel from your finger into the electroscope because it's attracted to that positively charged glass rod. So since there's an excess of electrons that are going into the electroscope, when you remove both your finger and the glass rod, the neutral electroscope will now have that negative charge.